stuff. You've heard of some of this stuff, otherwise I'm doing a terrible marketing job. So we're seeing a lot of device growth in the US or in the world. And in fact, we're outnumbered 2 to 1 as humans now by devices. So there's a massive number of these devices coming online, and they're all talking to each other. So lots of growth. By 2020, it's going to be 3 to 1, the ratio. So just again, more devices than there are people on the planet. So it's just very important trend to look at. And even more important is how much traffic are they generating, or how much are these devices talking to each other, talking to the cloud. 89 exabytes a month this year, and if you annualize that, that's over a zettabyte. Over a zettabyte of data being created. This is the first time we've talked over that. So these devices are not only outnumbering us, they're a lot more chatty than we are. So they talk a lot to each other to generate tons of data. So if you look at some examples of some of the data, or some of the devices that are creating this data, you have smartphones, PCs, 30 megabytes, 90 megabytes respectively. Intel just said this recently. But if you look at some of the online devices coming online in the near future, autonomous cars and connected planes are going to dwarf that of these typical devices that we're used to. So just massive amounts of data being created. So what I'd like to propose and what I've been evangelizing internally and externally is that we're actually going through a modern day gold rush, which is ironic for me because I'm actually in the same physical geography as where the gold rush was happening. But we're actually going through a gold rush, but with data. And right now, there's a big fight between all these tech companies, whether it's Facebook, Google, I don't care, you name it. Right now, it's a land grab for who owns the data. So they're all about who owns the pictures, who owns the text feeds, who owns the updates and tweets and whatnot. So it's all about fighting for who's going to be that incumbent, where is that final battle going to happen. So I'm going to give you a couple examples of types of data that are currently being fought over at the moment. The first one is text. So text is what has made the internet popular. And search is actually a great example of this. So if you look at Google's, for example, they're a very dominant player in the search space, extremely dominant. So they kind of are that incumbent in the space. And there are some potential new things happening that can actually disrupt that and displace them as the incumbent, but I don't have time to go into that. But a lot of these guys can actually be afraid of some of the trends that are happening. So this is, again, what made the internet popular, and this started everything. This is how programmers, this is how developers, this is how everybody in computer science thinks. So it's like if the user types in this text, or even if you use some fancy algorithms, you're looking at text, you monetize it. Location is a new one. This one I'm pretty excited about. Really wasn't popularized until the smartphone, so everybody has a GPS tracker in their pocket, and we all seem to be fine with that. But what's great about this is a perfect example is Uber. So Uber has been able to displace an entire industry, a worldwide industry, just by taking one piece of information sitting in your pocket, which is GPS, and they're able to find out that you need a ride to the airport before you even went out to hail a cab. So it's all about racing to collect that data. They were able to find out that there was somebody that needed a ride before the taxi driver even knew that person existed. So it's a race to get to the buyer. And that's kind of a theme that's going to be going on over the next decade. So another example that I'm more excited about and kind of scared about as well is photos. So photos, there's an old adage that a photo is worth 1,000 words, and it is quickly becoming that. So there's AI, more specifically deep learning technology. One of the most well-attended classes at Stanford now is a deep learning class. So and this, if you go back 5 years ago, that was not the case. So deep learning is this huge topic, a lot of money going into this. In Pittsburgh, a lot of AI intelligence coming out of Carnegie Mellon, a lot of the startups out there. That's where Uber actually started their self-driving car. No coincidence, or there is coincidence to where it's located. But photos, this is where the hottest battle right now for types of data. So if you look at Facebook trying to collect your data, Instagram, but Facebook saw a threat, purchased them. I don't know if that was the reason why, but anyway, they made a purchase because of a potential threat to their stronghold on photos. There's other types of photos being collected as well from other players, but this is where the hot space is for amounts of data. And with artificial intelligence, it's just going to make it even scarier for who's going to take the lead in types of data. So with AI, you're going to be able to monetize data even faster. Again, get to the buyer before the incumbents even knew the buyer existed. Just like that example with Uber, and then beating the incumbent. Somebody that's been running, taxis have been around forever, and all of a sudden, just because of one thing, Simple piece of information like GPS, it's disrupted an entire industry. We're going to start seeing these types of disruptions because of AI happen throughout the entire world. I don't care, outside of technology, it's going to disrupt every single industry. So, what I'd like to propose to you is that data, because we're going through this gold rush and this collection of data, and who owns it, who can monetize it, I'd like to propose that data is actually the new currency. So data has taken different shapes, and actually literally taking different shapes, from big rocks, that's my boss right there, beads, bullion, and now our Benjamins, and now bits. So bits is a very valuable piece of information. If you want to kind of look at it literally, you can look at some of these data breaches that are occurring almost on a weekly basis now, where some data gets stolen, and a company has to pay a huge fine or pay class action lawsuit money. It's worth a lot of money, this data. And actually Bitcoin and some of the other types of things are another literal type of currency. So what I want to do is kind of look at how flash relates to all of this, because that's what I do, is I sell flash, and more specifically focus on SSDs. But with flash being a way, I look at it as a medium or kind of like a method for storing your new currency. And so you have to be able to store it in capacity because of the amount of data that's being created and put online. You need to be able to store it efficiently. You need to be able to monetize your data fast, because again, that piece of information performance, that's going to be critical to who is going to be the new leader in whatever industry you pick. So it's all about getting performance and ecosystem. With flash, you need to be able to have a full integrated system. You need to take advantage of this new type of medium, because hard drives have been around for a long time, and so you need to really work with the ecosystem to drive it. So what I want to do is look at, is my pace okay? I'm kind of semi-speeding it up, but hopefully not too much. Okay, so pennies to dollars. So kind of looking at kind of an analogy of currency and looking at data. If I was to pay $100,000 in pennies, first thing you'd probably do is punch me, but then you'd have to find a way to store those pennies, and you'd have to get by a couple safes to store all of those pennies. Another way to actually effectively store your money or your data is to increase the denomination or increase the capacity of the drive in which you store the data. So if instead I can give you a dollar bill, you only need 100,000, and you can lower the amount of safes you need, or in other words, you can stop the data center sprawl that's going on with smaller hard drives. So the other thing that data is just like currency is, if I gave you $1 today, sit that in your pocket, every minute that goes by, but even over a year, the value of that data or the value of that dollar becomes worth less and less because of inflation. The same thing holds true with data, but it actually happens a lot faster. So what I almost propose to you is that data has hyperinflation. So data over time will have value, but the most important value it has is at the very beginning, the time that you acquired that piece of information, because that is fresh data. I know that a buyer wants a car, I need to advertise something to that guy right now. I see a trend going on that people are buying higher capacity SSDs, and I can see that. The faster I can act on it, the faster I can stay ahead of my competition. It applies to every single piece of information or type of data out there. If I gave you a newspaper and the date on that was a month old, you're not even going to read a single article. And I'm sure there's great articles in there, but you want today's newspaper. I don't care, you apply it to any type of data. The timing of the data is extremely important. So the last thing is you need an ecosystem, because if I gave you $1 and you can't spend it, you can't store it, you can't do anything with it, what good is that currency? Same thing as with flash. You need to drive the integration with all types of applications so you can fully exploit that kind of currency or that kind of data. Lots of stuff going on within the flash space, so a lot of work happening from, I don't care, you name it, Samsung, Toshiba, Intel, all of us are all working together to drive this industry forward, and it's moving at an extremely fast pace. I've been in the storage industry or enterprise storage space for almost 20 years now, and the amount of innovation I see going on, or the pace at which it's going on, is crazy. And in fact, it's impacting the enterprise storage space in which I'm from. So, just to kind of look at some key things that have occurred in the flash space, this is overall growth in PC, retail, or aftermarket, and enterprise. Over 50% growth this year. Crazy. So again, very exciting times, but more specifically, there's 3 trends that you may not know about. So within the next 12 months, hard drives have been going into notebooks for a long time, and this is something that I've been trying to get rid of for a long time, or actually a fairly short time. But for the first time in history, we're actually going to ship, as an industry, more SSDs into notebooks than hard drives. So we're hitting a threshold at which we are now the incumbent. So now hard drives are going away rather quickly. And in fact, to be honest with you, if there was more flash available, it probably would happen even faster. So another thing, and this is within Samsung specifically, but what I like about what I see in the trends in Samsung is it helps me see what's going on in the industry or will happen within the rest of the industry. Sometimes there's a lag in there. But SATA has for a long time been the main interface for many things, but mostly PC. For the first time, NVMe is actually, and this is already happening by the way, we ship more PCIe SSDs into PC than we do SATA. So this is another major trend. So another testament that hard drives are on the way out. To my knowledge, there are no PCIe hard drives at the moment. And that actually, I've said since I started, the moment a hard drive vendor puts a PCIe interface on a hard drive, they're not going to do it for the performance, they're going to do it because they have to, because the slots were designed for SSDs. But anyway, hopefully that'll happen. And the other thing that's happened that's kind of interesting, and this already happened for us here in North America, and it will happen for the rest of the world rather quickly, this enterprise space, we now ship more into the enterprise space than the PC. PC has always driven a lot of technologies in, like for example, hard drives. The hard drive guys look for PC for scale, and they make all their money on the enterprise side. We're actually seeing more bits ship in the enterprise space now, and this has to do with what's going on, a whole other topic, but the moving of data from storing it on the PC to storing it in the cloud, and this is naturally happening a lot of times because of the smartphone. So again, just to recap, you need capacity, performance, and ecosystem. And I'm going to talk to you about some of those things that Samsung is doing specifically in this space. So Samsung introduced a technology called V-NAND in 2013. We announced our 4th generation a couple months ago, and we're going to be shipping this product in this quarter actually. So 4th generation. Competition has finally introduced their first version of 3D NAND. V-NAND is what we call our 3D NAND. But we're well mature in this process. In fact, I've shipped over 30 million SSDs based on this 3D NAND technology. Furthermore, I've shipped over 30 million PCIe SSDs as well. So again, leading the space in PCIe and 3D NAND development. All flash is going to be based on 3D NAND at some point. Samsung is aggressively moving into that space, already has. And that's really our path forward. So we announced V1, V2, V3. Can you guess what's next? Very simple. Yeah. I think my first grade son has patterns that he has. I think he can answer this question. But yeah, so we introduced our 4th generation V-NAND. So this product has 64 layers. I guess it's not too important to focus on that. But what is interesting is the 512 gigabit density. So this is the highest density NAND. I mean, we already have the highest density with 256, but this is allowing, we announced a 16 terabyte SSD that allowed the SSD industry to pass up the largest densities in hard drives for the first time. That was last year. This is going to allow us to go even further. So that's really exciting. So if you look at that, what does that mean? I can fit in a single package. So if you were to crack open an SSD and look inside, you're going to see these different chips on there. One of those chips can now hold 1 terabyte in a single chip. So it's just crazy to think about how big these devices are getting, but physically getting smaller. Let's look at a couple SSDs. So what this allowed us to do is introduce what typically took a 2.5-inch drive to do. And when I started, 1 terabyte was not even something people talked about, even on the enterprise side, 5 years ago. And now in the PC space, we're putting all of that 1 terabyte capacity point into a single chip. So this is not only the flash itself, but this is the controller and the DRAM that goes along with it. So everything in a single package. And it weighs less than a penny. So if you look at that, you think you'd be compromising performance. No, you're not. You're beating even the leading 2.5-inch SATA drives. So you can get faster performance and better power efficiency. So you're getting all this, it's all goodness. It's almost like having a Tesla. Where's the compromise other than the price? But the price is actually a good story and if I had more time, if you guys ever want to talk about it, I'd love to. There's a lot of exciting things, especially on price, going on. So some things that we've worked on, and this is taking our same technology, but putting it into the data center space. We worked with Facebook on one of their Lightning platforms, and we're able to put 2 terabytes on these M.2s and cram multiple one of those into a chassis and get to really high densities in these platforms. So something else we noticed is that the M.2, is everybody familiar with M.2? You guys have all heard of that? So M.2 is designed around kind of the thin and light, or ultrabooks around Intel. And Intel really pushed these M.2 form factors kind of for board layout or battery layout and everything inside the PC. But what we realized is that these form factors weren't optimized for the data center space. In fact, they weren't even targeted towards that, to be honest. But all these engineers get creative and figure out ways of using different Legos and kind of building really cool castles and stuff. Well, anyway, they took the M.2, but what we realized is it was a lot of dead space. Because if you look at 1U, the M.2 is actually only going up to roughly here. So you have wasted space. We can actually do a lot more with that extra room. So we're working with the industry to standardize a wider form factor. So typically it's 22 millimeters wide. We're actually working on a standard for 32 millimeters wide, and that does make a world of difference. So millimeters makes a world of difference, and it allows us to get to really extreme densities. We're going to be able to go from our 2 terabyte current M.2 solution and go all the way up to 8 terabytes with that extra room. So very cool. And then you're going to start seeing a lot more chassis that are designed around this, designed around flash. So a lot of times all these chassis, whether 1U, 2U, 3U, 4U, I don't care, you name it, they're all designed around 3.5 inch or 2.5 inch drives. And then SSDs happen to play well in there. Now, a lot of players, a lot of ODMs, a lot of OEMs are designing M.2 chassis. They're designing PCIe-based backplanes. So the movement's happening. So in terms of like showing you trends of past shipments in this space for the data center and enterprise, hasn't happened yet. But I can tell you all of the internal conversations I have with all the players, it's happening. And it's going to happen fast, and it's going to come extremely fast. So another thing, so this is kind of the traditional piece. This is what's made PCIe. People think always PCIe about performance. It's not necessarily about highest performance, but that's what people thought. They always thought of Fusion IO when they thought PCIe. Not anymore, but that's what they used to think. This is that type of solution where it's kind of going after the really high performance. But look at this, 12 gigabytes a second coming out with our next gen PCIe SSD. 12 gigabytes a second. I couldn't even design an entire rack when I was in the storage industry to get that kind of performance. And now it's something that fits in the palm of my hand. So something else, I told you that last year we introduced a 16 terabyte SSD. This is the first SSD, or the first SSD to be larger than the largest hard drive. So kind of I love these kind of key milestones. They're all happening within my lifetime and all within the time that I'm involved, so it's really exciting. So HP, for example, we work with many partners, HP is one of them. They were able to take, because of the 16 terabyte drive, they were able to take 2 racks of their current platform and shift that into a single 4U chassis. So this is the type of thing. So it's not all about high densities, it's about what can you do about data center sprawl, what can you do about supplying power to all of this, cooling all of this. So that's what it's about. And I don't have slides in this because of time, but the pricing on SSDs is now cheaper than hard drives. Cheaper than 10K and cheaper than 15K. Now you can argue this, and what's allowing it to happen is not necessarily the physical price per gigabyte, but it's because of things like compression and dedupe. So compression and dedupe have allowed the enterprise space, such as players like 3PAR, Dell, and other similar players, to actually take that compression and dedupe and cross over the dollar per gigabyte line of hard drives. So we are seeing a massive growth. So big that we couldn't even see that this was coming. Our customers, the OEMs, couldn't see this growth coming. If I was to show you some internal growth charts of what we're seeing on the enterprise, it's amazing. It's insane. And it's because of compression, dedupe, and what's happening there. So enterprise space really taking off. And then with that V4, the new technology that my son could have guessed was coming, is the PM1643, and that's allowing us to double it and go to 32 terabytes. So again, another topic that I'd love to talk to you about further. I have so many like tangents I can go on in detail in this area, but 32 terabytes, you're getting to these densities that are going to make you rethink what an SSD is. It's not just a block device. It's going to start becoming or morphing into things that, I don't know, I would have never thought of. And now you have an army of them. I have, let's say 24 of these sitting inside a 2U chassis. 24 or 32 terabytes. These are servers in themselves. You should see the processor speeds of these SSDs. If you look at them, how many cores they have, the speed of these cores, how much DRAM is in them. It's an army of servers. So anyway, these kind of capacity points are going to make everybody rethink what does an SSD actually do. So a lot of cool things that are happening in the space, and I just covered a lot of these. So V4, or V-NAND technology, is allowing us to help the industry propel it forward. When Samsung innovates, it puts pressure on everybody to innovate. So that allows for Toshiba, for Intel, you name it, to also innovate in this space, which is all goodness for everybody. So healthy competition is great, and standards are great, and Samsung wants to help lead the industry towards that end goal of an all-flash world. So okay, so we introduced an auto cache software that allows us to actually improve performance on HDD-based systems. Basically, standard caching. Don't really need to go into detail into what caching is. But this allows you to see increased performance across the board. In the end, caching is just a hybrid solution. Ultimately, what I want is all flash, but you even see benefits on this. So I see even people doing hybrid SSD solutions, like a higher performance SSD and lower performance SSDs, and you also see benefits. Anytime you have a discrepancy between different performance tiers, caching will exist to some extent. So there's a new segment. We announced, we noticed that there was a gap between SSDs and DRAM, and so there was a need for a new solution. So we announced V-NAND, which is allowing us to help fill that gap and help address a need in that middle tier. So what we did is we designed a controller around this new type of flash. So we're basing it on our V-NAND technology, 4th generation technology, so it's very mature. It's not an exotic new technology that needs to be proved out to see if it works or doesn't work. We want to give somebody, or give our customers, a product that's already scaled, already in the efficiencies, already driving out all the costs so that we can give you a very affordable solution. So that was one of the goals we had. But what we wanted to do is look at some of the claims made on some of these exotic new technologies that haven't yet been proven, and we're actually able to beat those new exotic solutions with this technology. So this is something that our engineers have been working on, and we finally announced this 2 months ago. So this is kind of the best of the best in types of performance solutions. So all types of benefits up and to the right. So we see a lot of interest from data analytics. So you name it, whether it's autonomous cars or whatever it may be, and looking at artificial intelligence, which is huge investment going in this. The VC space is going crazy around this space. So a lot of stuff going on. This is the type of product that would fit into that space. Yep, and so some folks are pitching this exotic memory into PCs. I don't think that's needed. And so, yeah, basically some exotic technology plus a hard drive, and you get some increased performance. With just the standard NVMe SSD, again, weighs less than a penny. That little tiny thing can give you even more performance. Why do I need to complicate my architecture if you don't have to? So we don't really see V-NAND or these new exotic technologies going into the PC space.
When is that going to be available?
We have not yet announced. Oh wait, which one? This one? This one is actually. Oh, V-NAND is. We did not yet announce the actual shipping date of it. So we're announcing next year. So we do a lot of things with other players. This has to do with how I talked about the importance of the ecosystem. So if I can give you a fast device, but your software is not written to take advantage of it, then what's the point in installing an SSD? So we saw the need to actually work with other players out there, whether it's big database guys, whether it's specific applications, whether it's data centers, work with them to help enable that. So we're willing to put resources behind it and help those folks. We worked with VMware, worked with Dell. Hybrid solutions were all the rage for a while, and there was some nice valuations going on in some hybrid platforms, but now hybrids are quickly going away and going to all flash. Why? Compression and dedupe moved us below that dollar per gigabyte line that the enterprise guys care about. So now you can just go all flash. So I've even heard that some folks are pricing all flash arrays at the same price as hard drive based solutions. Why? If you cross the dollar per gig line of hard drives, you actually make more margin selling the product at the same price. That's why. So we work with folks like Microsoft, 84 gigabytes a second. So no bottlenecks in this system. No bottlenecks in this system. So 84 gigabytes a second. And this is what the new hybrid looks like. No hard drives, high performance PCIe SSD, and lower performance SATA SSD. So this is what the new hybrid is going to look like. So something we introduced, and NetApp was the first to actually productize this, and they were showing this off at their NetApp Insight event last week, I think it was. And they announced it with their ONTAP software, is multi-stream. This basically allows you to give more hints to the SSD. Remember I said you need to start thinking differently about what an SSD actually does? It's already happening, and it's happening in baby steps, but this is an example of what's happening. So you're able to actually tag I/O and tell it, I don't plan on holding this data that long. I'm probably going to erase it within the next day. Or maybe I'm going to store this one a little bit longer. Or, hey, I have a bunch of threads going in because they're trying to write as much data as they can to the SSD so they get the maximum performance. But the SSD has no idea that all these data, all this random data coming in is related. So this allows the SSD to become aware of what data is related, and so we'll try to place it all together so you get better endurance out of it. You reduce the write amplification. And NetApp was actually able to see and actually offer 3 times the amount of endurance that they were able to offer before. What does that also mean? It allows for lower costs because you can go to lower endurance SSDs, which endurance is the primary factor that drives price in SSDs. The other thing it allows them to do is reduce the over-provisioning on an SSD, which is a factor that goes in. That was impressive. Wow. So it allows you to reduce the over-provisioning. So instead of having 28% OP, that was very typical in the enterprise space, or even more, 60% OP, you're actually able to go down to 7%. What does that mean? Lower dollars per gig. So yeah, we worked with Ceph. So Ceph was designed around a hard drive, but we saw that Ceph was a very popular platform and actually gaining steam. So just by making some optimizations in Ceph, we're actually able to see dramatic improvements in performance. Dramatic improvements by moving to an SSD. We weren't able to see this before these optimizations because of bottlenecks in the way the software was written. So a lot of cool stuff I just talked about. So I think that's it.